Hey there, math fans. I'm going to talk a little bit about one of our homework questions, but it gives you another idea about moving graphs around. And the truth is, as I thought about this is why I left this problem. I do this all the time when I'm animating things. So like when I take this graph here, I make a lot of graphs like this for the various classes I do in 2D and 3D, and I have to do a lot of shifting. So how do I do that in an efficient way? You can see I have it down here at the bottom of the screen. You can see on the left there that I use the shifting skills. This is how I was able to program this because I knew about the shifting. You can see right here that I changed x to x minus a for that function. That's basically the answer to your question about finding this. But let me say a couple other things. I'll move this out of the way for just a moment. Not that. Let's move this. Okay, so a few comments. I imagine there's going to be some questions because the problem says you have a unit circle, and students might say, well, we haven't really talked about the unit circle. We have talked about circles. Circles, but the unit circle and its properties are going to be a big part of our next discussion. And then there's a bunch of functions here. They give you a line here. They give you a line here. And these are the things we're trying to shift around. So I think the problem has a good goal in that it's trying to get you just to mechanically shift things around and see what you can do. But in working with a student in office hours, I realized there's going to be some questions about some of the details. And so I wanted to say a couple things here. But ultimately, you can kind of see, what if I wanted to shift this point to some random place over here? And I wanted everything to move. At that point, when you have so many things, you probably don't want to have to resolve for all the equations. This is a practical situation where you'd want to move. So let's just call that something. How about 10, negative 3? So I do that. Okay, so the real practical piece of this is it's very helpful if you're animating or if you're moving things around, is to say, what do I need to do to all the points? Okay, now the quick version for the circle, you might already know, you just replace. If you replace this x with x minus 10, that does it. Because now plugging in a 10 here is like plugging in a 0 there. And then similarly with the y, you can say y minus negative 3 or y plus 3. So what you do when you shift the circle like that, you can also do with your equations in the exact same way. So let me illustrate that here. So if you wanted to move this line to here, you could do the same sort of replacing. So this gives you hopefully another perspective. You could replace y, just like we replaced y with y plus 3. You could replace that y with y plus 3. And you could replace the x with x minus 10. It's that quick. So that's really what this is about. Now, if you're going to clean that up, it's going to be something like y equals x minus 13 plus square root of 2. Now, the confusion in the homework is they say they want you to list the answers according to their y-intercept. And so I imagine I'm going to get lots of questions about that. So if you look, this one is going to have, so if I sort of label them, this line, whatever it is going to have the lowest y-intercept. So let's call that 1. So when you go to enter your answers in order of y-intercepts, that line is going to be number 1. The line I just found was this one, and that's going to be number 2. So when you go to do the homework, I imagine this is going to be the number 1 question I get. I hadn't really noticed this till I was working with a student in office hours, and I was like, oh no, everyone's going to be confused on how to enter their answers. So I wanted to make a comment that this equation, for in my case, is the one with the second lowest y-intercept. And you'll have to look at your picture to see that, because it's the second lowest y-intercept. Then you'll have to look at the rest of your graph to see, so this would be the third lowest y-intercept, and this would be the next. So I apologize for that. I mean, if I was going to write this question, I would want to basically make just people enter it in any order. But it is challenging to program these questions, so they made you do it in a certain order. So anyways, this would be, whatever equation this is, will be number 3, because it has the third highest y-intercept, and this will be number 4. And I basically showed you how to do it already. You'll just need to correspond. So equation 1 will be this one. And you need to replace the y with x plus 3 and the x with x minus 10. The other question I was getting in office hours was about the intersections. Now, there's actually many ways to do that, but one comment is that really doesn't have anything to do with the shifting. If you need to find this intersection, it's when the original circle and this line intersect. Another comment is this line right here is y equals x. So actually you could find the intersection of y equals x with this. Many people already know what that point is when x and y are the same on the unit circle. Once you know one of them, you know them all. Same thing happens in that problem. It says it wants you to list them in order in the following way. So again, I know that's what people are going to ask the most things about. So I'm going to try to say something here. So if it asks you to list the intersection points in order of increasing x and then increasing y, you're going to find this first one, whatever it is. Let's say that it's square root of 2 over 2, square root of 2 over 2. Those are not the smallest. The smallest is going to be over here, negative square root of 2, negative square root of 2 over 2. That's what you're going to list first. So I want you to do negative, positive, and then, negative, negative is what it wants. Those are the smallest. It's like an alphabetical ordering. That's what it wants. Positive, negative, positive, positive. So that really shouldn't be a long question, but it's a scaling thing. So I'm going to pull the picture back. So you can see this is useful. And then when I animate things, I basically hit play. So like if I wanted to move the circle across, here's what I would do. I would say, I want A to go from 0 to 8. And I want it to go slow. And I want it to go backward and forward. And then I just let it go. So it's going to go to 8. And then it's going to come back. And all I'm doing is shifting. That's kind of fun. So a big part of graphics is being able to do this. If I wanted to rescale, I know how to do that. I could make these all 2s. Cool, there we go. And I could even make that a slider. So I could add a few more, C and D. And I could say I want dy, and then I want C. And so I want you to play around with this because I think this shows the practicality. Yes, it helps us with drawing graphs. But I think in the future I'd like to design an activity, and you can let me know what you think, where we could play around with this. Whoa, I mean, it's sort of weird to, so if you make a negative, it flips. That's what we just saw. So I'm squishing it now. Let's make it so we don't flip. I'm squishing it. Whoa. Squishing it way down. You can make them go. Let's get rid of my dot for a moment. So we have the ability to do all those things. And with Care, you can learn precisely what they do. And that's like what you would do in a graphics course. So that you can move something around or rotate it or various things. Rotation is something we'll be able to do later once we learn a bit about our circles. But that's the point. So to me, that's actually a big part of this shifting and dilating that maybe in the future I could, if this would be interesting to you, I've kind of been thinking this might be a nice way, an interactive homework in this section. Thinking of designing a new homework for that section. All right, let me know what you think. Hope that helps.